Hi there! In this video we will be learning SQL through practical examples with a medical symptoms database. We will be exploring how to manipulate and extract valuable insights from our data using basic and advanced SQL queries. So let's start by taking a look at the database we will be working with. So heap is the name of our database, which contains one table whose name makes reference to respiratory symptoms, and this is exactly where we will need to run our queries. So in order to start interacting with our database and its table, we will run our first command, which is use. Heap. This first command ensures that all our queries are executed within the context of our heap database. Now, let's check how many records we have in our main table. So now that we have set our environment to our database, we can do this with a simple query. Select. So this function count is responsible of counting all the rows in the table, and the asterisks between parentheses here means we are counting all records. And with from, we specify the table we are obtaining the data, or from which we want to count the records. So by running this query, let's run it, we are getting this result, which is the total number of records in the table, giving us a quick overview of our dataset size before diving into more complex queries. So now let's have a complete overview of the dataset by displaying all columns and rows in order to fully understand the database we will be working with. And for that, let's run this query. So with the asterisk, we are selecting everything, so we have the whole table, the entire database. And as you see, this table contains data related to respiratory symptoms reported by patients, and the table contains some important columns. The symptoms column that lists the symptoms reported by each patient, age, sex, disease, which specifies the diagnosed disease or condition, treatment, which contains the treatment given to each patient, and nature describes the severity or the nature of the disease. So with this database, we are going to run some queries, and of course I will leave it in the description below so you can download it and practice with it and follow this video without any problem. Good, so here our goal is to obtain all records from this table where the patient's age is 12 years old or younger, and the nature severity is here, this column, is classified as high, so that means we will include only those patients with high severity. So we start with the set statement. With the asterisk, which tells the database to return all the columns. Next, we specify the name of our table, from where we get the data, and the magic happens in the where clause, where we set two conditions. Age is 12 years or younger, and the nature severity is high. So nature equal to high. And let's run our query. And as you see, we get only those with the conditions we specified in the query. So in this exercise, we should write a query that returns a list of all diseases present in the table, and this will be very useful for understanding what diseases are recorded in the database. So to do that, select distinct. This ensures that only unique values are returned in the result set. This is important to when you want to see each disease without any duplicated. And the column will be disease. From name of the table, we execute, and here we see all the different diseases that are recorded in the dataset. Pulmonary hypertension. So here you see all: pulmonary hypertension, influenza, pneumonia, chronic bronchitis, chronic cough. So you see, with just 2 lines, we get all this in return, which can be valuable for medical research, statistical analysis, healthcare management, and so on. Alright, here we should get the average age of patients diagnosed with asthma who have been treated with Mepolizumab. This would be useful since it could provide insights into the typical age range of patients with asthma who are receiving a particular treatment. Information valuable for healthcare providers. So here we will apply an SQL function that calculates the average of a numeric column. In this case, it will be age. Age. Alias. Name of the dataset where this data comes from. And now we will somehow filter the dataset to include only records where patients have been diagnosed with asthma and have received the Mepolizumab treatment. And which is the logical operator to combine multiple conditions in a where clause. And in this context, it connects two conditions: disease equal to asthma and treatment equal to Mepolizumab. Alright, let's try execute our query. So 21 years old is the average age we are looking for. In this exercise, we should focus on patients diagnosed with asthma, and we should count how many times each symptom appears among these patients and arrange them from the most to the less common, which means we should sort them in descending order based on the count. So we should start by selecting the column symptoms. So select. So after we select the column symptom, we should count how many times each unique symptom appears. Remember, an alias provides a temporary name for a column or table in a query result that makes the output more readable. Now from, which specify the table from which data is being retrieved, and the name of this table is res. And now we should filter rows from symptoms where the value in the disease, here in the disease column, is equal to asthma. So where now group by symptoms, because we have to gather together all rows with the same symptom listed in symptoms column. So this clause help us organizing the roles of the result set into groups based on the values in symptom columns. So it combines rows with the same symptom into a single group. Now we have to order the data in descending order. And finally, we will get the top 5 most common symptoms. And for that, we just have to limit 5. Now we will execute this sentence. So we get the expected result, but here we have duplicate entries in the result due to an extra space in symptoms column. So to resolve this, we can apply a function that removes any space like this one. So let's try by adding this function trim. And let's see the result. So this function essentially trims any white space character from the beginning and the end of the string, leaving this inner space intact. It's a very good function to clean up data and ensure consistency in string values. Now we will execute this sentence. So we get the expected result, but here we have duplicate entries in the result due to an extra space in symptoms column. So to resolve this, we can apply a function that removes any space like this one. So let's try by adding this function trim. And let's see the result. So this function essentially trims any white space character from the beginning and the end of the string, leaving this inner space intact. It's a very good function to clean up data and ensure consistency in string values. In this exercise, we should categorize patients into different age groups based on their age, counting how many patients fall into each group. So let's start with select. And now we will create the groups based on patients' ages using a case statement. Here we will assign the range of ages that we want to analyze. So I stopped the video to define all the age range to make it more dynamic, and the case statement allows you to make conditional logic within a query. Here we evaluate a series of conditions and we return a result based on the first condition. And in this particular case statement, we define all the age ranges. Each one specifies a range of ages, and the corresponding then clause assigns a label to that range. For example, in the first one, we assign this label. The label provides a representation of each age range, making the data easier to analyze. Now we will calculate the total number of patients in each age group. Now we specify the data source with from. Now we will apply the group by clause. And base it on age group, which will group the results by the age groups created in the case statement here earlier. Finally, order by. And let's see what we get as a result. And here we have the total number of patients corresponding to each age group. Alright, with this query we should identify the most frequently used treatment for a specific age group, which in this case is 15 years old. So let's start by selecting the column to be displayed in the result, which is treatment. Which represents the treatment, the different type of treatments recorded in the table. And then we will count the total number of rows for each treatment type and label the column. We will specify the table where the data come from. And now we will filter the rows so that we get only the ones where the age is 15 years old. And then we will group the rows that have the same value in the treatment column. So in this way we will show how many times each treatment is used among the filtered rows with where age is 15. And then we will order by descending in descending order, the count column that we will create. And finally, we will restrict, or we will show only one row, because this query purpose is to find the most frequently used treatment for people aged 15 years old. So by adding limit 1, we make sure that the query returns only the treatment with the highest count. So let's execute the So chemotherapy is the most common treatment given to patients who are 15 years old. In case you want to find the data from information between ages, you just have to modify this one and write between, for example, 15 and 30 years old. And here it changed to antibiotic. Good, so in this exercise we should count the symptoms for each disease and display the count next to each record. This could help analyze the frequency of symptoms for each disease, useful for identifying common symptoms per disease, and could help improve diagnostic accuracy. So select. And now for calculating the total count of symptoms for each disease, we will count the symptoms. And now for understanding the distribution of symptoms across different disease, we will use a clause called partition by. So here partition by divides the data by disease, creating separate groups for each. And then the count symptoms, this function count, calculates the number of symptoms within each group. This provides a specific symptom counting for each disease. We could have used group by, but partition by in this case is more suitable because it allows calculation within each group without reducing the number of rows in the result set. On the other hand, group by would merge rows and summarize data which may not preserve the detailed information needed for this case. But just for remembering, partition by separates data for calculation within each group, preserving individual rows. And group by does the same but reducing rows to summarize rows based on shared values. By this clause we are ordering the disease and symptoms alphabetically. So let's see the result. Alright, but the problem here is that we have a lot of empty fields and we want to exclude them. So let's filter out quickly the rows to avoid empty fields. Where, and inside the where clause we will have to use a condition. So first the column where we want to exclude the rows, which is symptoms, and then the condition is not null, and symptoms so it's not null condition filters out rows where the symptoms field is null, meaning it only includes rows where symptoms has non-null values. And this condition right here filters out fields where there's an empty string. So we are making sure that only rows with non-empty values are included. So let's try it out. It worked correctly, but only to the symptom columns. We want to include also disease. So AND operator. Can copy because it's the same. We'll change only disease. And here we have the expected result without empty values. So you see that due to the implementation of partition by, all the rows are intact. We are not changing them as it happens with group by, where it reduces the dataset into summary rows. So here it's about to determine the total count of cases, diagnose it with bronchiectasis, and calculate its percentage based on the total number of cases in the dataset. So let's start by counting the total number of times where the disease bronchiectasis appears. And now to calculate the percentage, we will take the following approach. We'll multiply the count of bronchiectasis cases by 100 to convert it to a percentage as a first step. Then we will divide this value by the total count of cases in the dataset. And for that we have to make a subquery. So we open another parenthesis, count, so as you see we had to make a subquery in order to obtain the total count of cases in the dataset, which is necessary for calculating the percentage. And this expression by multiplying the total count of bronchiectasis cases by 100, we make sure that the result is represented as a percentage rather than a fraction. And finally, we have to filter the data to include only rows where the disease column matches the value bronchiectasis. So now let's execute our query. So there are almost 2,000 cases of bronchiectasis, and it represents approximately 5% of all cases in the dataset. Good, so our goal here is to identify the most common symptoms associated with different disease. And to achieve this, we will use a common table expression. A common table expression is a temporary result set that you can define within a with clause, as we are doing here, at the beginning of your SQL query. This result set can be referenced throughout the rest of the query, making complex queries easier to read and manage. So inside these parentheses, we define a subquery that will calculate the frequency of symptoms for each disease. The common table expression, symptom ranking, will help us to modularize our SQL code by breaking down the query into more understandable parts. Now, inside the common table expression, let's select the disease column and the symptoms. And then we count of how many times each disease appears for each disease. This count is going to be defined by our famous function count. Yes. So the count function calculates the number of times each symptom appears for each disease. Next, we will use the row number function with a window function. And this part of the query assigns a unique value, and a unique row number to each symptom within the same disease, ordered by the count of times it appears in descending order. The partition by disease, this clause partition by, ensures that the row numbering restarts for each disease. Partition by, this clause is a powerful feature in SQL window functions. Here we are using it with row numbers, to create distinct partitions or groups based on the disease column. So what this means is that for each unique value in the disease column, SQL will create a separate partition. Within each partition, the row number, this function, row number, then generates sequential numbers based on the ordering specified. So in our case, partition by disease ensures that row number restarts its numbering for every distinct disease. This is very important because it allows us to rank symptoms independently for each disease category. Now let's sort the rows within each partition created by partition by. So order by sorts the row within each partition, and in our case we want to sort symptoms based on their frequency and ensure the most common symptoms appear first. So order by count desk sorts the symptoms by their count in descending order. This means the symptoms that appear most frequently will be ranked at the top. Next, we add symptoms to the order by clause to sort alphabetically in case two symptoms have the same count. Now we will assign an alias to the result of the row number function. Now let's reference our table. So still inside our common table expression that we use to rank symptoms by their frequency for each disease and sorted them using order by clause to identify the most common symptom. Now let's focus on an important part of our query, the data cleaning. Specifically, let's look at where, the where clause, which we will use to filter out null or empty values. So let's start by disease is not null checks that disease column does not contain any null values. Null values represent missing data which we want to exclude from our analysis. And next, this part ensures that disease column does not contain empty strings. So by this we are removing entries that might be present but have no real value. And let's do the same with symptoms, the symptom column. And now let's group our rows based on unique combination of the disease and symptoms column. And we achieve this thanks to our group by clause. And this means that all records with the same disease and symptom combination are aggregated together. So now we are done with the common table expression, where we selected the disease and symptoms column, counted occurrence, ranked them with row number, here row number, partitioned by disease, filter out null and empty values and group them by disease and symptoms. So as you see, common table expressions helps organize our data and perform complex operations like ranking, filtering in a clear and efficient manner, making it easier in this case to analyze symptoms frequency for each disease. So now let's focus on our last select statement of our query. So we are selecting the columns we want to retrieve from our data. In this case, we are selecting disease, symptoms, and the symptom count from our common table expression. That symptom count shows how often each symptom appears, and in this way we can identify the top symptom. And now do pay attention what I'm going to do with the from, because I will not link the from to our main table RESP symptoms. Rather, I'm going to do it with the symptom ranking, which is the alias of our common table expression. Remember the common table expression, this portion of code here. There is where we defined our logic. So the only thing that is left to do in the main query is just to invoke the common table expression by the alias that we defined right at the beginning. So by using from symptom ranking, we are pulling the results from the common table expression where we have already done the heavy part of our code, which includes counting the symptoms, ranking them, and ensure the data is clean. The common table expression acts as like the temporary table, providing a simplified and efficient way to access and transform the data. It just organizes and processes our data. The main work is still doing outside the common table expression, which is our main query. So now there's something left to do, which is the last part of our query, that is filter out our data to include only the top 3 symptoms for each disease. So this filtering step is going to where clause, and this where should point to this alias we defined here. So we leverage the ranks we assigned to each symptom using the row number function. This ensures we only get the highest ranked or most frequent symptoms for each disease. So in this way we ensure our results are focused on the top symptoms. So let's run our query. So the query results provide a clear overview of the top symptoms for each respiratory disease ranked by their frequency. For example, acute respiratory distress syndrome. For that disease, the top symptoms are distressing, faster heart beating, and pain. For asthma, shortness of breath, cold, fever, and you can see the same result for each disease thanks to our query right here.